Well, that raises a question. How is it that a function can fail to be differentiable? Well, here is the graph of my absolute value function in blue, and I can see that on the negative x-axis, this function is linear. It's just a straight line with slope -1. Well, hey, that's exactly the slope we calculated from our limits. Good job there. On the right side of the x-axis, on the positive side of the x-axis, the function is also linear there with slope +1. And both of these linear pieces are meeting at a sharp corner at exactly x equals 0. So geometrically, my function has a sharp bend in it. And anytime I see this kind of shape in my graph, I have a corner or a kink in that curve, then my function will not be differentiable there. How else could I not have a differentiable function? Well, there's an extra property of differentiable functions that I haven't introduced yet. And this is the idea that a differentiable function has to be continuous. So I'm not going to prove this. The idea is that if you have a slope at every single x coordinate, then your function should be smooth and not have any gaps in it. So that means that any place that my function is discontinuous, say a jump discontinuity or maybe an infinite discontinuity, that will be a place where the function's derivative does not exist. Well, what if we had an infinite discontinuity? What if we had a vertical tangent line? So if I try to put in a tangent line and that tangent line is actually vertical, vertical lines don't have a defined slope. So here would be some pictures of my vertical tangent lines. As I get closer to this coordinate A in my picture, my tangent lines are getting steeper and steeper in their slopes. Maybe it's a positive slope, maybe it's a negative slope. But at the coordinate exactly A, in actually both of these pictures, I have a vertical tangent line, so there's no derivative I can actually define there. So if you see any of these shapes in a graph of a function, so coming to a hard point, or having a jump discontinuity, or having a vertical tangent line, then the derivative of that function will not exist at the coordinate A.